The first kind of problem we're going to take a look at using our properties of logs is called expansion or expanding logs. So this kind of problem involves taking a single log of a big complicated expression. So say something like this. So I have the log, again, an arbitrary base, could be any base. So log base b, I'll just leave it as b for now, it doesn't really matter, of 2x to the fourth y cubed. So I'm taking a log of a pretty complicated, ugly expression, one single log, and I want to break it apart using my properties, which, by the way, I've included for everybody's reference here on the right, here in the upper right-hand corner. So these are three properties of logs. So remember, the log of a product is equal to the sum, addition of the logs. The log of a quotient, division, is equal to the subtraction, difference of the logs. And the log of something to a power is the power in front multiplying as a coefficient. Okay, so the question is, well, how do we get started? I mean, well, what do we do? How do we use these properties? I don't understand. How do you use these properties to split this apart into a bunch of different expressions? What order do I do stuff in? Okay, well, here's kind of a nice guideline. So think about this expression, 2x to the fourth y cubed. Think about PEMDAS. So what order would PEMDAS tell you to evaluate this expression in? Okay, well, there are no parentheses, so I would do exponents first. I would do the powers first, x to the fourth, y to the third, and then I'd multiply all this stuff together. So I'd do powers first, exponents first, and then I would multiply. So exponents and then multiply. Okay, well, when you're breaking things apart, when you're expanding logs, think of it in the opposite order. So PEMDAS would tell me I do exponents first and then multiplication second. So when I expand stuff out, I reverse the order and I do multiplication first and then exponents last. Okay, so in other words, when I use these, think about using these properties, I'm going to think about using the multiplication property first, this first one. Log of a product is the sum of the logs. And then after that, then I can think about using the power property, bring the power down and multiply in front. Okay, so I think about using multiplication property first and then the power property second. Okay, so when I do it step by step, when I expand it out step by step, it's going to look like this. So I'm going to show you all the steps at once and then I'll walk you through it. Okay, so here's what it's going to look like when I do it step by step. All right, so the first thing I do, remember, we're going to use the multiplication property first. So I think of this as a product. So what I did in this first line is I just wrote it just to emphasize with a multiplication sign and multiplication dot between each piece, just to emphasize that at first you're going to think of these as three separate pieces multiplied together. So three separate factors multiplied together. It's 2 times x to the fourth times y to the third. Okay, so I'm going to use the multiplication property first. So the multiplication property says that when I take the log of things multiplied together, I can break it apart as the sum, addition of the separate logs. So log of 2 times x to the fourth times y cubed, I'm going to break that apart using my multiplication property like this in the second line. So it becomes log base b of 2 plus log base b of x to the fourth plus log base b of y to the third. Okay, so to get from the first line to the second line, I use this multiplication property to split it up as additions. Okay, once I do that, then I can use the power property. So if I have a log of something with a power, that power can come down in front and multiply as a coefficient. So now when I look at term by term, log base b of 2, okay, that doesn't have any power, so that just stays as log base b of 2. But the second term, log base b of x to the fourth, now that one has a power, fourth power, so that 4, that power, can come down in front and multiply as a coefficient. So the second term, log base b of x to the fourth, becomes 4 log base b of x, 4 times log base b of x. Okay, in the same way, this third term, log base b of y cubed, that power 3, I can use the power property, and that 3 can come down in front and multiply. It becomes a 3 times a log base b of y. Okay, so once I've done that, then if I look at each of these three separate terms here, and I see, okay, is there anything else I can do? Is there any other way I can use these properties to split it apart? The answer is no. This is as far as I can take it. So this last line right here, this would be the expanded form. We'll call this the expanded form of this original compacted form. Log base b of 2x to the fourth y cubed, when I expand it, becomes log base b of 2 plus 4 log base b of x plus 3 log base b of y. Okay, so this is what we're going to call the expanded form, when you separate it out into a bunch of separate logs. All right, so let's do another example. So let's say for our second one, okay, let's take a look at this guy right here. Okay, so here's an interesting one. So I have log base b of this weird fraction, 5x squared over y cubed square root of z. So this crazy fraction right here. Okay, so once again, you think, okay, where do I start? What do I do first? I see a bunch of powers. I even see a root. I see a fraction. Okay, what do I start with? Okay, well, think about your PEMDAS. So PEMDAS would tell me if I were evaluating this expression, okay, never mind the log, just look at the expression itself. 5x squared over y cubed square root of z. What would be the order of operations? So I would normally do exponents first, and then multiplication, and then division. So exponents, multiply, and then divide. Okay, well, when you're expanding, you just reverse the order. So I'm going to do the division rule first. So I use this division rule first here, and then I use the multiplication rule, and then I use the power rule. Okay, so when you're expanding, go in the opposite order of what PEMDAS would tell you to do. Okay, so here is, let me show you, here's what it looks like when we expand it apart. Okay, so the first thing, remember, we're doing the opposite of PEMDAS. PEMDAS would say, in order to evaluate this expression, I would need to do division first, exponents first, then multiplication, and then division. Okay, so when I break it apart, I do division first, and then multiplication, and then exponents. So division first. So first I see it as a quotient, a division of two things. This big chunk on the top divided this big chunk by this big chunk on the bottom. So first I split it apart as a division using the division rule. So when I take the log of a division, that turns into the difference, subtraction of the two logs. Log of top minus log of bottom. So when I take this big fraction, split it apart using the division rule, it becomes log base b of 5x squared, the top, minus log base b of y cubed square root of z, the bottom. Okay, so first I think of it as a division, then I split it apart as a subtraction. Okay, then I'm going to use the multiplication rule. So the multiplication rule says when I take the log of a multiplication, that turns into the sum of the two logs. Okay, so when I look at this first part here, this first half, log of 5x squared, well, it's a multiplication, 5 times x squared. So then I split it apart as a sum. So log 5 plus log base b of x squared. Okay, so that's using the multiplication to split it apart as addition. Okay, now when I get to the second half here, I think of this as y to the third power times square root of z, y cubed times square root of z. So I split that apart as addition. So it's log of y cubed plus log of, now here I'm going to switch it out. You learned in a previous lesson that when I have roots, I can think of roots as fractional powers. So square root of z, I can think of as z to the half power. So I'm going to just switch it out here just to make this easier to work with, because we don't have a rule that deals with roots. We only have rules that deal with multiplication, division, or powers. So in order to deal with this square root, I have to convert it to a power. Okay, so I think of it as z to the half power. Okay, also notice that I put these last two, I put them in a bracket, set of brackets. That's because I'm subtracting this whole second half. So in order to make sure I get the signs right at the very end, I want to make sure I group these together because they both come from the same term. The second term splits apart is this. So I use these grouping symbols, these square brackets, around them just to remind myself that both of these are being subtracted. Okay, that subtraction sign here from the first step is going to carry over to both of those, going to distribute to both of those since they come from the same term. Okay, so we've done first we did our division rule, then we did our multiplication rule, split it apart. Now, finally, we're going to do our power rule, last our exponent. So if there's anything that has a power on it, we can bring that power in front. So if we step through each term, well, log base b of 5, there's no powers on that, so that just stays the same. Log base b of x squared, well, that one has a power of 2. So that 2, I can bring it down in front here. It can become 2 times log base b of x. Okay, going on inside the bracket. So the first thing in the bracket, I have log base b of y cubed. Okay, there's a power of 3. So that 3 I can bring downstairs in front. 3 times log base b of y. Okay, and then finally, the z to the half from the square root of z, that half power I can bring down in front as a half coefficient. So it becomes 1/2 log base b of z. So I've applied my power law. Now I look, and there's not really anything else I can do as far as the rules of exponents. There's no other scenario where I could use any of these rules to simplify further any of these 4 terms. So the last thing I'm going to do is I'm going to go here, remembering that this negative sign has to distribute to both of these terms since they both came from the same piece up here. So I'm just going to distribute the negative sign to each of these 2 terms and then take away the square bracket. So what I get at the end is I get these 4 terms here. I get log base b of 5 plus 2 log base b of x minus 3 log base b of y minus 1/2 log base b of z. Okay, and those minuses again come from distributing this negative sign to both of these 2 terms in the bracket. Okay, so this is the expanded out form of this original guy right here. Okay, so this is expansion or expanding logs. So taking a single log and breaking it apart into a bunch of separate smaller logs. And in order to understand what order you do stuff in, you think about your PEMDAS, and then you just reverse the order of PEMDAS, and then that will tell you what order to use these properties in. Okay, so this is expansion. So next we're going to take a look at condensing or putting logs back together, which is going to be just the opposite of this.